flow table. So this is the fourth step which we are going to design in this particular problem. So the word primitive actually represents the easy. So this is going to be an easiest. So just listen to it so you know whether it is easy or not. So for doing that, this side you take your present state. This side you take your input variables which are x2 and x1. Okay. Then you draw a thing like this. So you people are already aware of this Z1, Z2, Z3. These much data are already there. So this is Z1, Z2, Z3, Z4, Z5 and Z6. So okay. And then the input side, what you want to write is your 0, 0 because two variables, so 0, 0, 0, 1, 1, 0, 1, 1. Do you know the reason? No, to satisfy, to make sure race condition doesn't occur. So first one is Z1. Okay. So Z1, you can see from this diagram, Z1 is moving to Z2 and Z6. Okay. So when it is moving 0, 1, 0, 1, 0, 1, your value is your next state. So presently when you are seeing this Z1, this is considered to be the present state. In this particular time, the next state is Z2, the next state is Z6 for this particular Z1. And you people do recall another one thing. 1 is not possible for this one. You people. So first we can take 0, 1. 0, 1 is over here. 0 in 0, 1 area you put Z2. Z2. Okay. 0, 1. You have mandatorily made a thing Z2. So Z2 is your next state. And what is your output? With respect to this is your next state, the output is 0. So mention the output over here. See, only one thing you want to do. So here you are going to fill with respect to next state and output. And one thing you want to see is whether this both are same. If both are same only, you should mention the 0. Suppose here there is 0, here there is 1 means you should not put 0. Instead you should put don't care, or else you can even put dash. Anything is possible, anything is applicable. Put dash, it represents don't care only. Okay. So this part is over. Now it is going to 1, 0. So 1, 0 is Z6. So it's Z6 and output is same. So 0. And now come to the, so another self loop is there. So Z1 is going to Z1 itself. Output is 0. So Z1, 0. And make sure to put a circle like this, the most important thing, because this circle represents Z1 is moving towards Z2, which means present state and next state are same. You can recall the asynchronous concept, combinational circuit, memory. This is your next state, this is your present state. I said capital Y is equal to small y is equal to stable. That condition, when that condition achieves, you should mention 0, circle it over the stable state, and that's called the stable state. Now here 1 is not available. Since it is not available, you should mention with dash, comma dash, which means next state is not known, output is not known. So they are representing with this dash. This dash already you know it represents condition. So Z2. So just see Z2 is 0, 1, right? So 0 Z2 is 0, 0, 0, 1. So 1, 0 can't occur. 1, 0 as 1, 0. So put. Likewise Z3 is 1, 1, right? So 0, 0 can't occur. So Z4 is 0, 1, right? So 1, 0 once again, it can't occur. Then this Z5 is 1, 1. So 1, 1 means 0, 0. It can't occur. Then in 1, 0, 1, 0 means 0, 1. It can't occur. So first I selected the states which are not available for the particular present states. Then I am going to choose the stable state. So 0, 1, right? So 0, 1 is it 2, 0. The circle like this. Then 1, 1. 1, 1 over here, right? So is it 3, 1. The circle like this. Then is it 4, 0, 1. Is it 4, 1. Stable, put a stable like this, stable state like this. Is it 5? It's 1, 1. So is it 5, 0. and Z6 is 1 0, 1 0 is over here. Z6, put a circle like this, 0 like this. So almost this one is over. Now finally, what is the available still remaining things is the next state for the particular state. So Z2 is moving towards Z3. Z2 is moving towards Z3 and Z1, right? So Z2 is moving towards Z3, that is 1 1. So here Z3 comes, but here the important thing you want to focus is the output is 0 for Z2, but for Z3 it is 1. Both are different, so we can't predict the output. It can be 0 or else 1. So I am putting a dash. Then come to Z2, it is moving towards Z1, there is no issue with it. So Z2, Z1, comma 0. Now come to Z3 also just do like that. It is moving to 0, 1, that is problem the implicit table. For designing it, what I am going to do is first write the leaving this Z1, right? Z2, Z3, Z4, Z5 and Z6 in one column. Then row wise write Z1, Z2, Z3, Z4 and Z5. Okay, so between these different states we are going to make a comparison. Make sure there is any possibility a common terms or a common state is available over there, or available or not, we will check it out. That's the main purpose of implicit table. The box like this, and how the comparison can be done. So how to compare also I will teach you now. So first we are going to compare Z2 and Z3. Okay, so Z2 and I'm very sorry. And we are going to compare Z2 and Z1. This is Z1 and Z2. Then we will be comparing Z1 with Z3, Z1 with Z4, Z5, Z6. Then we will go to Z2 with Z3, Z2 with Z3, Z2 with Z4, Z2 with Z5, Z2 with Z6. This is how the comparison looks. So the shortest way of comparison is done by the implicit table. So we can go into the topic and okay. So how the comparison is made. So the thing is, what you want to check is very simple. You just listen to this part very carefully, so you will get a clear idea. Z1, same states, next state, same output, so no issue. Z2, same output, same, no issue. Here Z3, don't care, don't care, which means this can be neglected while comparing with this Z1 and Z2. This can be neglected. So Z3, Z don't care can be used over here. That's the meaning of it. Likewise, this can be neglected, and Z6, 0 can be used over here. So this is same, this is same, this occupies here, this occupies here, which means that is same. So Z1 and Z2, there is a possibility both are same. Likewise, compare all the remaining forms. So Z1 with Z2 is done. The Z1 with Z3. Okay, so while comparison in the easiest manner, leave this part. Suppose you are having this don't care values, just leave this part. Check out with the remaining things, so it will be easier. So when I am going to compare Z2 with Z3, I will leave this part and I will be leaving this part. I will check whether these two are same. So here there is no issue, but here there is an issue. So Z1 with Z3 is not possible. Z4 with Z1, Z1 with Z4. So here also Z4, Z2, once again not possible. Z5 with Z1, Z5 with Z1. Here also Z4, Z2 not possible. Z1 with Z6. So Z1, 0, no problem. No problem. Z6, 0, which means it is possible. Then come to Z2 with Z3. Z2 with Z3. No problem. Here there is no possible. Then Z2 with Z4. Here no problem. Here once again a problem. Z2 with Z5. Z2 with Z5. So Z2 with Z5 no problem. Here once again a problem. Z2 with Z6. No problem. Here there is a problem. So Z2 is not possible with anything. Then come to Z4 with Z3. Z3 with Z4. No problem. Okay. Okay. And no problem. So Z3 and Z4 is possible. Z3 with Z5. No problem. Okay. But not possible. Okay. Cancel. Then Z3 with Z6. No problem, no problem. That's a problem. Cancel it. Then Z5 4 with Z5. Z4 with Z5. No problem. Okay, but there's a problem. Z4 with Z6. Z4 with Z6. So no problem. It's no problem. No problem. There is a problem. And finally Z5 Z6. No problem. No problem. No problem. No problem. Which is this one is equal. So from this point, what you can get is so it's not clear. I hope so. So I will mark this or the tick or the possible variables. So from this point we can get Z1 is equal to Z2 and Z6. Z1 is equal to Z2 and Z6. Likewise Z3 is equal to Z4. Likewise Z5 is equal to Z6. So these are the three different variables we are going to get. Three different possibilities of combination we can make from this implicit set. Three are related to each other. So only it actually helps in finding the relationship between the states. Okay. So in the same manner, next we are going to the the sixth step, which is called as merger graph. Some people even finish this part and tell it's a merger graph. That is also acceptable, but anyway, a perfect show we will show over here. So we got these states, right? So mark the states like Z1, Z2, Z3, Z4, Z5 and Z6 like that. So you can randomly also do it up to your wish. Then after marking the state, Z1 and Z2 are equal. So I will draw a line like this. Z2 and Z6 are equal, which means Z1 is once again equal to Z6. So I will draw a line like this. Z3 and Z4 are equal. I will draw a line like this. Z5 and Z6 are equal. I will draw a line like this. Now what you want to do is, if I remove one of this line, make sure then the merger graph it actually helps in finding the compatibility between two stable states. What's the meaning of this? It's a stable state, am I right? So now we are going to find a compatibility between the two stable states. So how it is done, we can see. Just remove this part. So what happens? We are losing Z4 and Z3, which is not possible. Remove this line. What happens? We are losing Z2. This is not possible. We remove this line. We are losing Z6, Z5. This is also not possible. But when I remove this line, so this line I am going to remove, what happens? Z1 is there, Z6 also there because it is connected. Z1 is connected with Z2, Z6 is connected with Z5. So this is the main advantage of merger graph. Using this graph, you can make sure to eliminate one extra stable state which is actually occupying unwanted space. Okay. Now we can move to this part. So we can make sure from this process we can get a clear idea. Z1 is equal to Z3. Z1 is equal to Z3. Z4 is equal to Z3. Sorry, Z1 is equal to Z2. Z4 is equal to Z3. And Z5 is equal to Z6. Got it? Then next step is 5, 6 over. Now we want to once again redraw this primitive flow table, simplified one, because we are going to take only Z1, Z3 and Z5. This states only we are going to represent here, changing remaining all with respect to Z1, Z3, Z5. So you will be writing over in this picture, you will be writing over like instead of Z6 you will be using Z5, like just like that. So you will get only 3 tables. This step is not available actually. Actually we showed only 8 steps, but if you want to make this also as a step, I didn't make this as a step. If you want to make this as a step, no issue. So I'm going to make a reduced primitive table. Okay, so that's what I'm going to make. So how I'm going to make this using this, guys. So Z1 is equal to Z 1 is equal to Z2, right? So I will yeah, so I will make this graph, it looks like this. So 0 1 1 1 1 0. So I will map it. Z1 is equal to Z2. So this is, I will compare these two, which is considered to be the best. I want to place it here. That's the thing. It's a very easy one. So when I comparing these two, this is stable one. So I choose this. Then comparing these two, this is the stable one. So I choose that. So then comparing these two, there's no way. So this one only I should go for. Then comparing these two, there is 6 comma 0. This is the only possible combination. Okay. Then do the same thing for Z3 is equal to Z4. Z3 is equal to Z4. So this two Z1 comma dash. These two Z4 circle comma 1. These two Z3 circle comma 1. Z6 comma dash. Then finally Z5 comma Z6. So Z1 comma 0. So Z1 comma 0. Z4 comma dash. Z5 circle comma 0. Z6 circle comma 0. So got it. So from this, there is another one change I want to make. Now I come back these two things only. Okay. So now I am going to do from here, from this part I am redrawing this. Okay, so don't get too much hold up. Actually, you can directly draw this diagram, but anyway you should have a clear understanding. So I thought of drawing it 2 times. Okay, so it's up to your wish to choose which is required. Okay, now we can go to the required thing. So see here, Z1. So Z1, Z3, Z5. Only 3 states we are going to see. So Z1 is there, no issue. Z2 is there. Z2 is there. Z2 is not there. Z2 is equal to Z1. So here Z1 you want to mention Z1 comma 0. Z3 is there. Yes, we are going to use Z3. So no issue. Z6 we are not going to use because I said you already. Z5 only I am going to use. So Z5 comma 0. Likewise do for the second thing. So Z1 comma dash. Z4, Z3 circle comma 1. Z3 circle comma 1. Z6 is once again Z5. Z5 comma dash. Then Z1 is once again useful. Z4, Z3 is equal to Z3. Z5 is available. Okay. Z6 is not available. Instead of that, Z5 comma 0. So this is your finally driven or shortened or whatever you call it. This is the available states, that is Z1, Z3 and Z5, and because of that reason I will also name them like 0 0, 0 1 and even 1 0, but still 1 1 is not available because the there is, with respect to 2-bit there is 4 possibilities. Now remaining 1 possibility, which is 1 1, I will wherever 1 1 is going to occur I put don't care condition. Got it. And now we can go to the next step, which is your step number 8, which is K map. So don't get surprised because this data was available over here. Just to make it simple, I redrawn everything to make it in a short manner. Got it. So we can go to our step. So the reduced primitive table, flow table is the required thing. So we got that one. And after that, step step 7 we are going for, which is the K-map technique we are going to use to get our required values. So we can see how it is possible. Okay. So for that, see whatever I am telling, just try to understand. So I am going to make a K-map with 4 cross 4. Why I choose 4 cross 4 is we have a state, we have 3 states and maximum possibility is 4. So one side 4. Plus other input variables also like x2 and x1, there is 4 different input variables, so 4. So that's why I choose that one. So 0 0 0 1 1 0 1 1. But here what we are going to mention is same thing, 0 0 0 1 1 0 1 1, and this it represents the input variable over here, and the one which is over here represents your states. So I already mentioned that we are having z1, z3, and 1 0 is z5 actually, because still so I just didn't tell about this thing, I hope so. So once again I will tell. So there's 3 states, right? So I will consider this 0 0 0 1, this is 1 0, which means my 1 1 state is still missing, so I can mention this don't care, which means if data I want to add, I will mention it don't care. So in the perspective point of view, since I said here I am going to represent my states, I am going to follow on with Z1, Z3, then 1 0 is Z5. So I will mention here Z5 is equal to 1 0. So 1 1, it's not available with respect to our problem. Okay, now how we can copy paste this value over here? Over here we can see, and before doing that, while copy pasting it, assign this value. I just forgot to do that. Assign this Z1 is equal to 0 0 over here. Z3 is equal to 0 1 over here. Z5 is equal to 1 0 over here. Just like that, assign, and then copy paste the value here. So for Z1 it is 0 0 comma 0. Z1 is once again coming, so 0 0 0, and Z3 is coming, which is 0 1 comma dash. Z5 is coming 1 0 comma 0. Then Z3 we are going to do for this one. So Z1 first it is coming, so 0 0 dash. Z3 is 0 1, so 0 1 circulate to 1. Z3 is once again 0 1 circulate 1. Z5 is 1 0 1 0 comma dash. Then finally Z5 is there, so Z5 it's equal like 0 0 comma 0. Z3 represents 0 1, so 0 1 comma dash. Z5 represents 1 0 1 0 comma 0. Z5 once again represents 1 0 1 0 comma 0. So it's done. You have perfectly mapped this part in your schema while assigning a value to this states. It's a very good thing. Now we can, but still here 1 1 is not available, which means don't care. And do remember, in some problems, instead of this dash, while you are mentioning in KMAP, you will be using X. So if you want, it's like most of the problems they are changing it to X. So it's mandatory. I won't also do, otherwise you will get confused or something, because sometimes place here. So yeah, okay. So I put X, which means that this symbol I have converted with X. That's all. So, both represent same thing. So no need of worrying about anything. So now the next part is now we want to compare. See, this guy can go to this part, which means 0 0 can go to 0 1 or 1 0, but not to 1 1. So which we call race condition. This guy, this thing we want to check again and again. So here also you are going to check that. Check whether this guy is moving. Okay, no issue. 0 0 no issue. 0 1 no issue. 1 0 no issue. If 1 1 is there, that's an issue. So this process, this first one is paka. Come to the second one, that is Z3. This is 0 1, right? It should never go to 1 0. This is the only thing. But it can go to remaining things. 1 0 is there. I check. Oh my god, that's 1 0. So put a marker, mark it. Okay. Then we can go to 1 0. 1 0 means 0 1 should not be there. 0 1 here it is. So 0 1 should not be there. So mark it out. Now what I am going to do is a small thing. The same race condition concept I am going to apply over here. So please do watch it carefully so you can get some clarity in it. Here you know that first we will talk about this. This can't change to this. Okay. It can't directly change to 1 0, but it can change after converting to 1 1 or else after converting 0 0, which means 0 1 0 0 then to 1 0 is possible. Race condition, no issues will be there. Am I right? So considering this, what we can do is either we can choose this part or is this part, but this part is already perfect, so we don't choose this part. Instead you can choose this part, that is 1 1, because 1 1 there is an empty space, no nothing, no issue is there. So for that particular reason, what I am going to do is, here I mentioned don't care, right? I will remove that don't care. I will just copy paste this value over here. Instead of this value, instead of here, I'm going to paste 1 1. I think you got an idea. Huh? You got it? Same thing now if I am going to apply for this. Here it is 1 0. 1 0. Now I can directly convert that to 0 1. So I should either choose 0 0 and move here, or 1 1 and move here. 0 0 I can't choose. It is a perfect state. So I will go on with 1 1. So 1 1 here also just copy paste over here. So 0 1 comma x. Here you mentioned what else? 1 1. It's a very simple thing. In our problem, there is no issue with x here output. Suppose you have some issue with output, you can put even root can and you can follow on. It's not going to be a big problem. Okay, got it? So this is the simplest way of this is how you want to check the race condition in each and every process of this particular sum. And now we will go into the next step, the diagram. Before going to the diagram, I want to mention one thing. Mark two variables like a, b, x1, y1, whatever you want. Mark this with a, b. This is your x2, x1. Okay, already I stated this part. Now here x2, x1, here ab, here x2, x1, ab, here x2, x1, ab, and you people are know that 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 0 0 0 1 1 0 1 1 0 0 0 1 1 0 0 0 0 1 1 0 1 1. Okay, now we can go to the part. Here I am doing the process with respect to A. Here I am going to do with respect to B. Here with respect to output. Okay, what's the meaning of that is with respect to the state. So this A and B is actually this part I am going to mention. So this will be your A, this will be your B, and this will be your output. So this A which is available in this line, A, copy paste it over here. So what we will get is 0 0 x 0, 0 0 x 0, then 0 0 0 1, 0 0 0 1, 0 0 x 1, 0 0 x 1, 1 1 1 1, 1 1 1 1. So the first value. Then come to the with respect to B state, whatever available with respect to B is over here. So 0 0 x 0, 0 0 x 0, 0 1 1 1, 0 1 1 1, then 1 1 x 0, 1 1 x 0, 0 1 0 0, 0 1 0 0. Then come to this output. This is your output. You are familiar with the things. So yeah, okay. 0 x x 0, 0 x x 0, 0 1 0 1 x 6, 0 1 x x, x 1 x 0, then 0 x x 0. So this is the required, this is how I separated all the things from your K map that we got from the reduced primitive flow table. Now we can combine all the terms, so we can get right the equation. So this term we can combine, this part we can combine, yeah, I will use this, and this part we can combine, this part we can combine. So 3 combinations. Here we can see what and all we can do. This part we can combine, and this part we can combine, and yeah, this part we can combine, and this part we can combine, and finally here this all we can combine. Yeah, got it. So once after this came up simplification, I just moved on with the answers A, B, C. I'm not focusing too much how to get the answer, because you people are very familiar with the answers, I hope. So I thought of not doing it, and after this getting A, B and C, I had drawn A for a separate line with inverter, separate line with inverter x2, x1. So four different values I got. Then just applied this operation in logic diagram level over here, and I got A. This operation in logic level diagram over here, and I got B. Then the output is equivalent to B. So this is your output too. So it's over. So this is called your step 8 circuit diagram. Required circuit diagram you got like that. If you finish, it is absolutely wrong. The reason is there's a small thing you want to do. What's the thing is, in asynchronous signal you got some combinational circuit in the first video, or the first asynchronous level concept. There's a delay element in the fundamental level of modeling, which is given as a yeah, feedback line should be taken from here, and this should be connected towards the A. Likewise, for B, a feedback line should be taken, and this should be connected towards the B, because yeah, this B is available over here. So that it can routine the process in the asynchronous level concept. This is the major important thing. Just don't forget to add it, because this feedback section is not there, means there's no asynchronous level of the designing. This sum not only carries 12 mark, the entire of unit is available in this diagram. The reason is you studied like implicit merger graph. People will be asking more 4 marks from this kind of things only. They will be giving you the K-map over here and ask you to draw the diagram, or in the K-map they will ask you to solve the race condition. So what is the race condition? You got a very clear idea, I hope so. And thank you once again. Be safe, be happy. Thank you.